So I've got to play with this, and as you can see, it looks like an explosion in a DTI factory. I've got a finger clock down in the bore on the taper, and it's running out, you know, without spending hours on it, about 2/100ths. The face is running out, this is imperial clock, about 1/2 thou, and the OD is running out about 4/100ths, maybe 3/100ths. So I don't think, you know, I could mess about with it, but I've actually played with it by rotating, and the point where this is high is where that one's high, so on and so forth. I think it's actually pretty good. I think the fact that I clocked it up on this one, and that it's 1/2 thou out here, I have tapped it back and forth, but you know, as much as I do, I either make it worse or get back to 1/2 thou, is amplifying this one because of the tilt on it. So I think that overall that's within a couple of 100ths. So if I was to flick it round, hold it on this sort of diameter here, again clock the face in, and clock it up, I think I'm going to be within a couple of 100ths. I think. Time will tell, let's see. So I must have spent half an hour clocking this up, but I've finally got it to something that I think is about right. I'm seeing 1/100th of a millimetre on the face and 1/100th of a millimetre on the top, and I'm chasing them round and they both move in, and 1/100th of a millimetre is what I'm seeing. So the next step, I'm going to attempt, and I know this material's tough, so I'm running nice and slow. I'm going to attempt to drill a hole in it right through with an 8mm drill. Now I've no doubt that when I get the carbide tip tool out, you know, the boring bar, that it will manage to drill this material as tough as it is. But I'll give it a fighting chance, bit of cutting compound and what have you. Let's see. Well, it's marked it. And I think it's just taken the edge clean off the drill. We'll come back, we'll have another look at that. So I'm going in with a 6mm drill first. A coated one this time. And I seem to be having more success. It is drilling. But my, this is hard stuff. So the 6mm went through. And now I'm putting the 8mm through. The amount of force that it took to get that 6mm through was unbelievable, and it's actually hit the part out the square again. So I'm going to have to clock it all up again. But I'm going to rough it out, see how I get on, do the donkey work before I clock it up. So rough it all out and then clock it back up at the final. And that's broken through. So having gone through with a 6, I'm now trying to go through with the 10, and it is actually cutting. So I have a feeling that this is case hardened. This stuff is genuinely harder than Chuck Norris. It really is. I'm getting a bit of chatter, but then I am stuck out of the chucker fairway. But I am getting a very good service finish in my register. Now going forward, I know that the 3 holes in this plate are not correct for the 3 holes in the headstock of the lathe. So I am going to have to use an adapter plate. So where am I at the moment? I've got a 20.5 hole through the bore. I've managed that. and it is concentric. It may not look like it's running true, but that chamfer is actually not true to this face and this face. Before I put any finishing cuts on, I'm roughing it out. I'm going to go back, re-clock it, recheck it, make sure everything's perfect. I'm going to do this rebate 2.5mm deep to a diameter, a clean-up diameter. I may even try the little aluminium cutting tips because they've got a much sharper profile, smaller radius, and may give me a better surface finish and reduce the load on the tip for my finishing cuts. We'll see. This should take me to around 2.5 deep. And I'm going to have a backing plate. I have a backing plate which I bought when I bought the lathe for just such an event, which fits perfectly on the headstock and is cast rather than this hard stuff that I could drill to match the existing bolt pattern on this collet chuck. So it's going to need a register on it, which I can turn in situ on the headstock, and then this, as long as this register's all true and happy, will fit to it. And it's a lot simpler to machine that cast to a diameter than to get this to a known size with it being so hard. So this is now at a point where it's just about, that's it, ready for me to attempt some finishing cuts. So after much hard work, I roughed all this out, bored out 20.1 mil, something like that, 20.3 mil, dug into the back 2.6 mil deep, and opened it up to like 64.8, something like that. It had all moved because I was roughing out. This was throwing probably about 600ths, and the face was throwing about 2 thou. So I clocked it all back up. A couple of the jaws had come a little loose. Well, not a little loose, but you know, not as tight as original. Tightened it all back up all the way round, clocked it, tapped it, clocked it again, tapped it. This is now running a 1/4 thou, perhaps a 1/4 thou. There is a slight movement of the needle. There are a few little imperfections in the grinding and what have you, but yeah, so I was happy with the way it was this way, and within 100th on my clock this way consistently. I mean, I can give it 100th by just yanking on the chuck, so yeah, I mean, that's pretty good. Then I've come in using the specialist tips for aluminium, running the speed very slow, and taken off 2 thou of this back face out to a given 0 on my DRO, then come back in and actually bored it to the back face again with the special tip for aluminium. No shattering, no creeping, no anything, probably because the dimensions on the aluminium grade tip are much sharper angles. It's a much keener edge, greater top rake, blah blah blah, and it's taken a lot of load off the tip, and you know, it took away all the chattering. It actually cut beautifully nice silver sort of swarf as opposed to the blue stuff I was getting before, and has left a good finish, I would say, on the diameter and on that face. Now of course my issue is the 3 holes, and having an issue with those 3 holes means that I can't tap those 3 holes for studs and just fit it onto the head, because the material's far too hard for me to tap. But I do have this backing plate. 3 studs go in here, straight into the headstock. This is all board ground, just going to need a good clean up. It's been all sat in wax paper and goodness knows what, and there's little sharp edges, and oh, it's a bit rough, but it is a good fit. So what I can do is put this up directly onto the head instead of the chuck, skim the OD if necessary, skim this face if necessary, and turn this register sort of a couple of thou shallower than that, so that when I pull down on the OD onto this diameter, which is going to be turned, and onto the diameter here, which is going to be turned, it should fit and run true. Again, let's just watch this space. So my next step, put a couple of little break edges on here. I mean, that's a little job I got to do. Perhaps try and dig one on the inside as well. And then I may attempt to true up this chamfer that's on the back, because it's just bugging me, but that's another thing. Take it all down, rip the forejaw off, and then put this up onto the headstock and machine this to suit this diameter. So I've taken the register diameter to within 2 mil of finished size. I haven't looked at this yet, but I did clock the OD and it was pretty good. It was within 100th again. I'm just taking a skim across this space, which is where the collet chuck will actually sit. 0.05 skim off it. It hasn't quite cleaned up on the outside edge. Just to get me somewhere near so that I've got a 0 mark. Just into my corner there, which was at 3.1. Let me just set that. Drops another 2 thou off there, set that to 0. That has now cleaned up. Again, the chamfer on the front corner is throwing. On this top corner. Only slightly though, only very slightly, so I probably will just dress that up with a 45-degree tool. Okay, so there's my 0 mark. That may well get another little skim once I've done this OD. Okay, let's just unlock the carriage. As I said, I'm about 2 mil off finish diameter on the register. Let's just touch them. I'm just taking the skim off this into my 0 on the DRO. And we'll have another measure. So what am I looking for? Approximately, I'm going to leave it about 0.2 up. 63.7 as it turns out. And that's 65. So I know I can go another mil off the diameter. Plus half mil aside. Gently, gently. Literally is a break edge, it's nothing. Still no chance. I'm going to keep going like this and creep and creep and creep up on it. I'll bring you back when it finally starts to fit. As you can see, it's resting there. It's just trying to fit. I think I've just caught the break edges of the two. Same again. One tiny little scratch. I may go half a line this time. There we are. I can see that it's cutting, but it is next to nothing. In fact, it hasn't even removed the tiny break edge or anything there yet. There, that was the difference. It just goes on. I mean, it just goes on. Unless you've got it perfectly square. No. And it's on. Okay. Now I need to make this step correct, which is going to be 4 thou less than it is in there. only took about 0.1 of a mil. Okay, with that, other than drilling the 3 holes, tidying up the chamfer, putting a slightest chamfer there, just tidying up that chamfer on the inside, should be it machined.